Hello. Alvaro, Ana, Carlota, Emna, Mario, and I are going to present you our project based on a dataset that had as dependent variable life expectancy. First, we are going to present you how we chose the dataset, how we prepared it in order to work with it, then how we analyzed it, and finally the conclusions we came up with. Firstly, we decided to choose this dataset as we thought that the dependent variable life expectancy gave powerful insights as it provides important information about health at a given population level in terms other than death. This information can be used for actuarial purposes such as planning and policymaking. Our goal is to generate insights to increase the measure of life expectancy in countries. And our population of interest is the current world population, as we have data for many countries worldwide and we want to increase their life expectancy.
To begin the process of analyzing the dataset, it is first necessary to explain the procedure we follow to prepare the data. First of all, we carry out a research to find the dataset. During this process, we found datasets in which some variables depended on time, which is why we had to continue the search until we found the life expectancy dataset. This dataset is compiled from a 15-year study done by the Global Health Observatory, a data repository from the World Health Organization. The study is made up of 193 countries in which 22 variables were studied. Once we had the entire dataset, we performed an analysis of each variable separately using RStudio and Tableau. In addition, we defined which variables were considered quantitative and which qualitative, with a total of 22 quantitative variables and 2 qualitative variables. Finally, after performing different analyses on each variable to determine if there were enough outliers to discard the variable from the analysis, and after substituting the missing values for the means, we were able to perform multiple linear regression analysis and residual analysis.
As Carlota mentioned before, we analyzed each variable and came to the conclusion that we had to discard 2 of them, which are GDP and population. So for GDP, we had 448 missing values, and although it doesn't exceed the 20% limit, we decided to exclude it because they came from many different countries. The box plot, it can be seen that there are many outliers corresponding to countries such as Austria and Hungary, where the economic status is higher in comparison to others. Secondly, for the population in this variable, there were 652 missing values, which does in fact exceed our 20% limit. Therefore, we decided to exclude it in order to avoid an unreliable analysis. And from the box plot, you can notice that there's a huge difference between the data and the outliers, telling us that most of the countries in the dataset have a smaller population, and only a few have large populations. There were a total of 294 outliers, which belong to countries such as India, Indonesia, and Brazil, where the number of inhabitants was far superior than the mean, which is around 13 million.
Going into inferential statistics, different methods or techniques have been used in order to analyze accurately and deeply the data. First of all, a multiple linear regression model was created with all the variables of the dataset, excluding just country, because it is a variable which does not affect the life expectancy, as are the values from the different indicators, the ones which define the economy and social status of the country. In order to create a model more appropriate, a selection of variables was done by understanding individually the relationship of the qualitative variables with life expectancy, and also the correlation between the quantitative variables throughout correlation metrics. Afterwards, the reduced model was created, which indicated the variables more related to life expectancy, and moreover, a residual analysis was implemented to understand more the data used.
After understanding the variables in this dataset, how they're going to be measured, and setting the report's main goal, 3 different specific goals need to be defined. In the case of the first specific goal, it is believed that the more alcohol consumed, the lower the life expectancy will be in countries. This is to understand the relationship between the amount of alcohol consumed and the life expectancy. The second specific goal is, it is believed that the more under 5 deaths, the lower the life expectancy will be in countries. This is to understand the relationship between under 5 deaths and the life expectancy. Finally, the last specific goal is the average life expectancy of the world in previous years, more specifically in 1999, was 65.91 years. Based on the sample data in this dataset, which only includes 145 countries, it is believed that the life expectancy will increase. What we want to do is to test if this statement is true. The approach used to answer the specific goals are the following. So for the first specific goal and for the second one, what we have used is the test slope of a simple linear regression model. In the case of the first specific goal, the independent variable is the alcohol, and for the second one, it is under 5 deaths. Finally, the third specific goal is going to be answered using the inference based on one sample, in which we want to test if the hypothesis 0 is equal to the mean population of 65.91.
Once the best model was created, after removing some variables such as polio, percentage expenditure, or fitness 5 to 9 years, due to its redundancy observed in the correlation matrix, with the new model, it can be observed that those variables with the highest relation are adult mortality, diphtheria, and income composition of resources. Also, this new model gives us that the 93.18% of the sample in life expectancy can be explained by using just these 16 variables as predictors. Besides, according to the residual standard error, 94% of the observed life expectancies are expected to lie within plus or minus 4.914. When the residual analysis done, the following conclusions were obtained through the resulting graphs. The data is linearly and normally distributed, as it can be seen in the graphs of the left side, and on the upper right corner, the graph tells the homogeneity, but the data used in this study seems not to be homogeneous, more or less to be a bit curved. And for the last graph obtained, it can be contemplated that there are no outliers within the red dotted lines, so it was not necessary to get rid of those outliers.
For the last part of the insights, we have the prediction end. So the World Health Organization wants to estimate how the life expectancy can increase by having two fixed values. So the first fixed value is the BMI, which is fixed as 23, and the alcohol consumption is into 0.5. So what we've done is create a new data with variables such as status, developing, adult mortality 70.51, or total expenditure as 10.91. So after running this command of new data prediction, and the prediction interval with 95 confidence interval is constructed, and when running the command with the optimal settings, we obtain that life expectancy is between 74.38 years and 86.71 years.
So we all know how big of an impact on the world COVID-19 did, especially by decreasing the globalization, but also slowing down the life expectancy. We decided to do our presentation about life expectancy before COVID, and our main goal was to generate insight to increase the life expectancy, especially during this time. And to sum up, we noticed that life expectancy depended on different factors such as death indicators, social and economic indicators, and confirmed of diseases. But when we correlated our result, we saw that the two factors that had the most impact on life expectancy was adult mortality and income compensation of resources, and these two are the ones who affect the most the life expectancy of a country. However, we had some problems during our research. We were limited by the absence of data. In fact, we didn't have any information about the US, and that data could have changed a lot our result. But we would like to have more data about life expectancy during period of times that we can relate with some historical catastrophic like World War I or World War II. I hope you liked our video and thank you.